読者の皆さん、こんにちは。角田郁雄です。今日はアメリカのプレイバックデザイン、新しいシリーズが登場します。エーデルワイスシリーズと言います。今回は、その CEO であるアンドレア・コッチさんとオンラインでインタビューすることができます。アンドレア・コッチさんというと、皆さんもよくご存知かもしれません。ハイレゾのオーソリティ、DSD の生みの親、いろんなことを言われてますけど、なんて言いますか、もう学者的と言いますか、オーディオの枠を超えたエンジニアだと思います。で、もうすでに私はありがたいことに、約20年間ぐらい、お付き合いをさせていただいて、本当に僕はオーディオの中でもハイレゾを推進するという点において非常にインパクトを受けた方でいらっしゃいます。で、特に印象深いことっていうと、2010年ちょっと過ぎた頃でしたでしょうか。アンドレ・コッチさんとお会いした時に、MPS5 で、何か、リクエストすることはないかということを尋ねられました。その時即座に出たのが、パソコンから DSD、USB 伝送したいという話をしましたら、それは面白い、やってみようということで、約半年から8ヶ月ぐらいで、実現したっていうのが、記憶に鮮明に残ってます。それから、DSD のことについては、本当に僕はあんまりよく理解してなかった。そんな折に、こういうポジティブフィードバックっていう文献を読んだり、それから、どんどん DSD が、高いサンプリングレートになってきました。2.8 から 5.6、今度は 11.2 という具合で、これは一体何だろう、本当にいい音のスイートスポットってどこなんだろうというような、論文も読まさせていただきました。以降、オーディオの、仕事という中においても、デジタルのあり方っていうのをね、本当の意味で教えていただいたと思ってます。そういう、アンドレア・コッチさん、今日オンラインで、インタビューできますことを非常に、嬉しく光栄に思っているところです。では、アンドレア・コッチさんを紹介いたします。日本では、プレイバックデザインというと、本当に人気のね、SACD プレイヤー、ハイレゾプレイバックシステムとしてものすごく人気が高い。コッチさん、ちょっと経歴についてお話しいただけないでしょうか。
I had a unique opportunity when I was working at Sony to be involved in the DSD project, with Philips together. And we created many different technologies, but one of the main duties was for me to design the recording equipment so we could demonstrate DSD. And that was key. And so I was at the beginning of DSD and had to explain to the world basically what is DSD and what is the advantage.
僕の記憶の中ではやっぱりすごく印象深かったのは、EMM ラボから、それからプレイバックデザインに移る、そういったところで、世界にもない、ソノマ編集機、レコーディングをして編集して、という機材を作られました。これは全部 DSD プロセスで一貫されてますね。そういったところがすごく印象的で、EMM のラボの時代、それからプレイバックデザイン、本当にいろいろ勉強させていただきました。実際に、プレイバックデザインを立ち上げたその経緯なんかちょっとご紹介いただけますか。
When I was working for Sony and we created the DSD format, I developed the Sonoma workstation with many engineers, with 18 engineers. So it was a big project. And part of that project was we needed converters, A to D converters and D to A converters. And we didn't have the capacity to do the expertise at the time. And so I hired Ed Meitner, at EMM Labs to help me design the converters. So he did all the analog designs and I did all the digital designs. But those were the first pure multi-channel DSD converters in the world. Everything was built, discreetly, with no chips, with no standard chips in the chain. And that created Sonoma, and with that, we were able to record pure DSD recordings in many different studios, including in Japan, and demonstrate to the world what DSD is capable of, how much better it sounds than PCM or any other recording system that was created so far. And that was the key, to my career, basically, I can say. And I was lucky to be with Sony and be involved in DSD and study the whole background. And then after Sony finished the SSCD project, unfortunately, I continued with what I have learned so far because I believed in DSD. It was a good format, and I believed this needs to be carried on. And that's when I basically started Playback Designs to develop superior digital products, digital to analog converters and CD, SSCD players. And that was in 2007, I think. And I'm still doing the same thing, always improving on algorithms and software, and trying to come up with new products.
そういった経過っていうのはものすごく生の音楽、生の楽器の音、それとレコーディングした音の、やっぱり差を見極めて、DSD っていう方が PCM よりもアナログに近い、現実的な音に近いっていうふうに判断されたんでしょうか。
As you maybe know, every A to D chip in recording basically creates a DSD, some sort of DSD format, and then converts to PCM. So it's always a two-step process. First, you convert to DSD, from analog to DSD, and then from DSD to PCM. And the idea was that what if we just take the conversion from DSD to PCM away, and we leave DSD as the recording format? It's one step less. So less processing usually means improved quality. And that's the basic idea behind DSD. And then there's many new forms and many new technologies and algorithms. But the basic idea was to reduce the complexity and the algorithms in the conversion from analog to digital by taking PCM step out.
Positive feedback.
Exactly. Yes. You're very good. Very good.
私は随分勉強させていただきました。Positive feedback.
Maybe a little bit of history. When DSD was developed in the early 90s, I think, or middle 90s, 95, the state-of-the-art sampling rate was 64 FS, so 2.8 megahertz. And meanwhile, clock rates went up, sample rates went up, and we realized and it's much better. And so the idea came up, the higher the better. So 128 FS, 256 FS, 512 FS, and all the crazy things. And the idea was always, 64 FS was good, so 128 must be better, and then 256 must be even better, and so forth. But as always in life, there is no free lunch. There's always a point when you have to pay the price. 64 FS, the bandwidth, the usable bandwidth of audio is a little bit narrow. It's maybe 20 to 25 kilohertz. That's very narrow. That's like CD. But when we go to 128 FS, it becomes double. So it's basically 40 to 50 kilohertz. And that is very nice. We can do smooth filters, just very gentle behavior.
コッチさんとインタビューして、いかにコッチさんが DSD の対価であるか。まあ僕からするともう師匠先生の世界ですけども。で、ここで今一度ビギナーの方、それからこのファイルウェブの読者のために、DSD の優位性、それから音の良さっていうのを簡単にご紹介いただけないでしょうか。
As we said before, we're taking processing out of the chain. So the conversion from DSD to PCM is taken out, and usually less processing means better quality. That's on the A to D side, but on the D to A side, there's also an advantage. And when you think of PCM, there's many different bits, but not every bit is the same weight. The LSB, the low significant bit, is low significant, and the MSB is very important. So when you convert that to analog directly, with a ladder, you have to basically match the resistors very, very precisely. But that's impossible to do, ultimate precision. So there's always some kind of distortion, nonlinear distortion inherent in the PCM conversion. If you only have one single bit, they're all the same. So that nonlinear distortion is not happening in the beginning. So that's the most important advantage of DSD. And with DSD, you can also do noise shaping. Well, you can do that with PCM too, but it's inherent in DSD. And so you can basically push the noise down in the audio frequency and move it up to the higher frequencies where you don't hear it with your ears. And that's inherent in DSD. That's usually resulting in very gentle filters. With DSD, the filters now, they're very, very gentle, or like this, very, very gentle. And so DSD is a better match to our ears, the way we hear. And I think that's probably one of the most important features of DSD, that it is more true to transient behavior, short attacks, quick rises or quick decays, like in music. A piano note, you hit a piano note, and it's a very sharp attack and a slow decay. DSD is very good in translating that into digital. PCM will do some pre-ringing and then decay. PCM has this pre-ringing effect because of the brick wall filter. And that's the digital noise. There's always this digital noise that we say, and it's unnatural because it does not exist in nature. DSD does not have that. So there's multiple advantages, and if you add them all together, DSD as a whole, if done right, it's a superior format, and most audiophiles can hear the difference.
今の説明も端的に申し上げますと、PCM だとどうしてもインパルス応答のこの波形のところで、前側にプリリンギング、後にポストリンギング、こういうものが発生して、こっちさんの説明によると、ピアノの音、例えば、聞いたとき、DSD は、そのプリリンギング、ポストリンギングがないので、自然の音の立ち上がりだと。それから自然の音の階調が見えてくるということでしょうか。非常にオーディオファイルに馴染む音だという、ことだと思います。 で、実際開発段階で、コッチさんは FPGA でアルゴリズムを駆使して、DSD の音作りをするわけですけど、こうやってる作業の最中に音が見えてくるんですか？
Well, there's two ways, to design audio equipment, and you can measure, and then you always use sine waves, test tones, and you improve the measurements and get it really nicely, so it measures nicely. But in reality, human ear or music is not sine waves. Music is full of transient, not using sine waves. And when you look at the behavior of music, the changes, the constant changes, that always results in the pre-ringing effects, and that's very challenging. If you have sine waves, then you never run into the problem of pre-ringing. And so you have to understand a little bit how the human ear works, how we hear, and why do we hear? Why do we even have those ears? That's a very interesting question to ask. So I ask many doctors and audiologists, how does our ear work and what is so special about it? And I started to understand how the human hearing really works. And so I say, up to a certain point, we have to measure, but then going beyond that, that's only ears. And we have to understand and design things. And if we, see that the measurement is maybe a little bit worse, but it sounds better, that's what we're doing. So when you measure all our equipment, Playback Designs, maybe it doesn't always measure as good as other equipment, but when you play music, it behaves much better than any other equipment because of that. Our algorithms are designed for the human ear and not for sine waves.
いや、今までインタビューにない素晴らしいお話を聞かせていただきました。またしても感激した次第ですけども、ちょっと話は変わりますけども、昨年インターナショナルオーディオショーで、すごいもう驚愕級のパワーアンプ、ドリームシリーズの SPA8、が登場しました。ドイツのパートナー、一緒にやっておられる方が、一緒に開発されたということなんですけど、この点についてやっぱりドリームシリーズの目指すところっていうのがあるんでしょうか？
Well, we have been working together for, since the beginning. And as you know, every DAC is a small amplifier as well. So we developed many different amplifiers, many different DACs, and we also developed the IPS3, which is a smaller amplifier, integrated amplifier. And it was very, very good. And we thought, all this know-how of an experience in amplifier technology, we should build a statement, a flagship product for amplifiers to basically tell everybody that Playback Designs knows how to build amplifiers, because that's part of the DAC. And when we started with the SPA8 project, we started with a relatively small amplifier, and it was maybe, it doesn't fit on the screen. It was still big, but not so big. But then we started experimenting with the power supply, and we added, instead of one transformer, we added two transformers just to play around and get experience. And we found it makes a difference. And the same thing with the capacitors in the power supply as well. We took some large capacitors, and then we said, well, what happens if we take the next size, bigger one? And we just played and tried it, and it made a big difference. So we said, we have to do this because this is our flagship product where we tell the world, Playback Designs knows how to build amplifiers. So we have to go with the best. So by the time we were done with our, and for future, we can take smaller caps, smaller transformers, smaller components, maybe less output stages to reduce it from 800 watts to maybe 400 watts or 350 watts. Then the whole size becomes smaller. But I think as a first step, it was important for us to set the bar very, very high. And then we can come down a little bit.
最後にこのファイルウェブの読者の皆さん、興味津々の、モデルが登場するようです。エーデルワイスシリーズですね。なかなかドリームシリーズっていうのはもうハイエンドです。エーデルワイスは多分形からすると、少し求めやすい価格にもなってくるのかなというふうに想像されますけど、このエーデルワイスシリーズについてご紹介いただけますか
？The philosophy of the Edelweiss series is basically what you said. More people can buy Playback Designs products. And as you, Tsunoda-san, know, we had the MPS5. That was our first product. And the performance was actually very, very high. But then we came out with the Dream series, and the performance is even higher than the MPS5. But we always received the feedback, we want something that replaces the MPS5. And so that's when we thought, we have to basically take the Dream series technology and put it into a different chassis, a different package, and maybe reduce the amount of power supplies and components and so forth to make it less expensive. And that's what we did. But we tried to maintain the performance as much as we could, and at the same time save in cost with the chassis. The Dream chassis is very expensive. It's very beautiful, but it's very expensive. And so we went back with the IPS3 chassis, the integrated, and we made modifications to it because that was a beautiful chassis also, but it's less expensive. And so we tried to save money wherever we could without impacting the sonic performance very much. But there's always some trade-offs, of course. For instance, the Dream series player, it has two power supplies, one for analog and one for digital. And it has one board for digital and another board for analog, separate. In the Edelweiss series, we put everything on a large board together, but we used new technology to separate digital from analog. And we only use one power supply, but it's a new design of a power supply that has better shielding and is more suitable for a product that has analog and digital. So we made a few modifications with new technology that helps, and then we were able to reduce the cost. And we think, we have something that is certainly better than the MPS5, and it's close in some relation, to the Dream series, but of course it cannot reach the same level, but it's very close.
今ご説明いただきましたように、新しいテクノロジーで、Dreamシリーズ、に限りなく近づけたっていうところが、非常に興味深いところです。正直まだインターナショナルオーディオショーで、プロトタイプ、ほとんど筐体だけ、 拝見したところですけど、これから実機を視聴させていただき、また使い方なんかも、このウェブサイトで、紹介できればなと思ってます。これから先エーデルワイスシリーズっていうのは、モデルを増やして展開っていうのがあるんでしょうか。
The Edelweiss series was a very, very tough product to develop. It took us a long time, and we had to do three prototypes because it never really, achieved the performance that we wanted. But now, finally, this is in production, and hopefully, we have a little bit more time now to do next products. In the Edelweiss series, we already have a pure streaming interface with no DAC, no drive. That's the MPSX, and then we have the DAC and the player. But beyond that, we're working now on the amplifier, and I'm not quite sure yet whether this will be an Edelweiss product or a Dream product. I think we will expand more into analog products because we know how to build them, and we don't have many analog products. We have many digital products, but we need to expand in analog products.
どうか今年、できる限り、11月か12月の東京インターナショナルオーディオショーに、来てくださるといいと思ってるんですけど。
I would very much love to. And, Japan is one of my favorite countries to come to, for an audio show. And, last year and the year before, I couldn't. But hopefully this year, it's possible again.
本当に今日は長時間ありがとうございました。もう間もなく、日本に、エーデルワイスシリーズ到着すると思うんです。詳しく紹介していきたいなと思ってます。
But it's always very nice to see you, and I respect you, what you're doing very, very much. And I hope we can travel soon again, and we can have face to face, not Zoom, and shake hands again.
今日は本当にありがとうございました。
Thank you, Tsunoda-san. ありがとうございました。
ありがとうございました、アンドレアコーチさん。